Top of the morning to you, Sioux High Earth Science students. Well, it's 5:30 in the morning right now for me anyway. You are most likely still asleep. Regardless, welcome to our next astronomy podcast. Today we'll start talking about another often confused phenomenon, auroras. You may know them by their common name, the northern lights, which is in itself confusing because there are southern lights as well. So get your notes out, something to write with, and let's shine on. First of all, reproduce the diagram of the sun in this slide on the right-hand side in your notes and label it correctly. So reproduce the diagram in your notes and label it correctly. Now the sun's surface temperature is approximately 6,000 Kelvin, which, believe it or not, is much cooler than the interior, which is several million degrees Kelvin. Write that down. Now in the sun's atmosphere or corona, you see the corona right here, the temperature rises again to several million degrees Kelvin. Get that in your notes. Now at these temperatures, collisions between gas particles are so violent. Remember what gas particles we're talking about, hydrogen and helium. They're so violent that hydrogen atoms disintegrate into charged particles called electrons and protons. Write that down. Now we call these particles ionized material. And the ionized material has a name that you've heard before. It's called plasma. Write that down. So those charged particles, protons and electrons that get generated by the sun are called plasma. Now this plasma flows outward in all directions and becomes known as the solar wind. Very important to understand that, so get that in your notes. The plasma flows outward in all directions and becomes known as the solar wind. And we'll see some artist depictions and some real pictures of those kinds of situations here in a bit. Now, observations of comet tails originally gave scientists the first hint that the sun produced a solar wind composed of these charged particles. Now, remember from our study of Comet Ison that the tail of a comet always points away from the sun. We now know it's because the force of the solar wind is what causes it to be away from the sun. Write that down. So the tail of a comet always points away from the sun. We now know that it's the solar wind that causes that. Now, if you look at this picture here, you're going to see now the solar wind now being ejected out into space by the sun. You already know that the tail is composed of gas and dust. So here's our comet. We know that this tail is composed of gas and dust. And now you also understand that the gas and dust is driven off the icy comet by the sun's heat and blown away by the solar wind that you see here. And now bathed in sunlight, the gas molecules break down and are excited, producing a characteristic glow that you see here. This glow is responsible for the visible light from the tail. Now, you need to find a way to write that down. Get that in your notes. Now, the solar wind is mostly hydrogen ions. Remember, an ion is something that lacks an electron. And it's also made of electrons. So the solar wind is mostly hydrogen ions and electrons. Write that down. Also write that the solar wind carries the magnetic field from the sun into space. like is shown here in the right-hand diagram. So it now ejects the magnetic field from the sun into space, like you see here. The solar wind varies tremendously in speed and density. Its speed and density tend to go up when it comes from active regions on the sun, like sunspots, solar flares, and coronal holes. Write that down. That's very important. You see now a solar flare depicted here. You see a sunspot on the sun that the artist has put in there. Those all now cause an upsurge in the solar wind. Now the solar wind streams outward through the entire solar system. At the distance of the Earth from the sun, 93 million miles on average, solar wind originating from around the equator on the sun takes about 4 days to reach the Earth. Write that down. That becomes very important. Now on to solar wind events that can cause stuff to happen on our planets, and more specifically on our planet. First of all, let's talk about eruptive prominence. Write in your notes that an eruptive prominence is a blob of 60,000 degree gas over 80,000 miles long. So write that an eruptive prominence is a blob of 60,000 degree gas over 80,000 miles long. Now you can see a prominence here on these slides in the lower left. You can actually see a couple of them. There's one there, and then there's a big one right here. Eventually those are going to become something like solar flares or whatever, but it starts as a prominence. The gaseous blob shown to the left in each image is what we're talking about. These eruptions occur when a significant amount of cool, dense plasma, remember plasma is ionized gas, escapes from the magnetic field of the sun's atmosphere to streak out into space. Write that down. Now, how does that affect Earth? Well, eruptions of this sort can produce three major disruptions in the Earth's near atmosphere. One, it can affect communications. 2, it can affect navigation systems. And 3, it can even affect power grids. Now, remember in the slide before, we said it takes about 4 days before that solar wind hits the Earth. Now you hear a lot of times scientists now predicting those disruptions because they know when solar activity is high. So it's important to know that 4-day gap so they can warn people. Here's an image captured by NASA's Skylab during an active phase in 1973. It shows a very large solar prominence called a solar flare from a very active sun. You can see it down here in the bottom right. When the sun is more active, observed as sunspots and other changes, the solar wind blows harder. Write that down. Now the Earth is shielded from a full blast of these particles, plasma, by what's called its magnetosphere. Write that down. You see the word right up here, magnetosphere. Also write that the magnetosphere is a large bubble of magnetic field that deflects the solar wind. So write that the magnetosphere is a large bubble of magnetic field that deflects the solar wind. Now this is an artist's depiction of the blast of the solar wind in white. So you see here in white now is the solar wind. with the Earth and its magnetosphere, that's these lines right here, depicted as the curved lines coming from the Earth. Now you also see some satellites in here that have helped us detect those, that NASA has launched. Now we see a drawing showing the blast of the solar wind as it reaches the Earth's magnetosphere, or its magnetic field. Now we might have a pretty good idea that the sun is spewing out charged particles that stream toward the Earth, and that they're the cause of the auroras, or otherwise known as the northern and southern lights. But how does this make the sky glow? Well, what happens is that some of the particles in the solar wind are captured by the Earth's magnetic field and speed up as they travel down the magnetic field toward the aurora ovals. That's what these are right here. These are the auroral ovals. And what you see now is you see the Earth's magnetic field deflects these toward the poles. They deflect them toward the North Pole. They deflect them for the South Pole. So that's why we call them the northern lights and the southern lights. The northern lights are these particles that get deflected to the North Pole, and the southern lights are the ones deflected toward the South Pole. The northern lights are known as the Aurora Borealis, Borealis. Now we'll see a slide of several slides of that here soon, but get that in your notes right now. Now these particles, plasma particles, gain energy so that when they blast into the atmosphere, they actually cause the air to glow. Write that down. Now when these high energy particles collide with oxygen and nitrogen in the Earth's atmosphere, some of the energy is turned into light, and we call these auroras. Write that down. Here are some awesome pictures of auroras. The one on the left is of the southern lights, Aurora Australis, and the one on the right is of the northern lights, Aurora Borealis. Both were taken from the shuttle. If you've never had the chance to experience one of these events, do yourself a favor and find out when they're supposed to happen next, and hope it's a clear evening. Not only will you be amazed and awed, you will now understand why they are happening. Okay, now off to Moodle to answer some questions. See you next time.